Good afternoon, ladies and gentlemen. My name is Dr. John Belkowitz. I'm here from Intelligent Concrete. Whitney, say hi.
Hi.
We're getting into our practice mix designs, back into them again. We've been getting a lot of work and prepping a lot of materials. So I'm not actually doing any mix design, like making mixes. So I don't know why I have an apron on, but our Uncle Russell made this for us, so thank you very much. And see, he says I never wear it, and I actually used it today.
You're doing mixes today?
What's that?
You're doing mixes in a little bit.
Well, we're not doing mixes over here. We're just doing the practice mix design. So the mix design that we're doing today is for interior slab, 4,000 psi, F prime is C. So really want to shoot for somewhere around 5,200 psi for our design strength. So we looked at both a 0.47 and a 0.58 water cementitious ratio. I think in the calcs we did a 0.47 going for that higher strength. So pretty excited for that, and we're pretty excited to get into it. So stay tuned. I've got to do a little camera moving. So anyway, what we're doing is our given is on our right. We're doing practice mix design number 3. We're doing a 6-inch reinforced concrete slab interior. So non-air entrained concrete, maximum slump allowed by ACI 211. And remember, ACI 211 is designing without admixtures. It's just this water cement ratio, volume based concept, 27 cubic feet in a cubic yard. F primacy is 4,000 psi. I believe if we look at ASTMC, or is it ACI 214, without any known mixes, we have to bump that up to around 5,200 psi. With anything greater that's 3,500 psi, I believe you either add 1,000 or 1,200. Let's just call it 1,200. And we looked at both a 0.47 and a 0.58. The math that we have is for a 0.47, and we'll tell you how to apply it for a 0.48. So our course, so we're designing for a cubic yard. We've got to use a number 467, designing for a cubic yard at 1.25 cubic feet. For a coarse and fine aggregate, we have absorption of 0.7 and 1.2%. Moisture, we have 1.3 and 6.3%. And our specific gravities, we've got 2.70 and 2.59. A dry unit rotted weight for our coarse ag is 98.2 pounds per cubic foot, and our finest modulus for our sand is 2.68. So we're going to start ACI 211.1. Step 1 is going to be recommended slumps for various types of concrete. So we're going to start with our slump. Let's see if I'm in the right place. Yep, so slump. And if you look at table 6.3.1, for pavements and slabs, it says a maximum is 3 inches, the minimum is 1 inch. So for slabs, we're going to do a 3-inch maximum slump. And then what we're going to do is jump over to page or table 6.3.3. It's page number 8. And with a number 467, non-air entrained concrete, and I believe the aggregate was a crushed and angular aggregate, so we're not going to be taking any water out of it. If it was a rounded rock, we would be taking it out. But for our water, we're going to say it's 300 pounds. Again, because we have 1.5-inch aggregate. We want a 3 to a 4-inch slump, a maximum of a 3-inch slump. 300 pounds per cubic yard for our water. And yeah, we should be good with that. Yeah, our approximate air content is 1%. And again, I'm taking this out of table 6.3.3, 1%. And we're good to move over to the next step. Okay. So we said we wanted 5 or 4,000 psi, really looking for 5,200 psi with that standard deviation or that percent error. So we're looking at 5,000 psi, non-air entrained concrete. Our water cementitious ratio is going to be a 0.47. Now I'm putting an asterisk in red by this because you see what we ended up doing. What we ended up doing was running this mix in the lab 3 times, and we found that to get without admixtures to get to that strength that we need based on the cement that we were using, we had to use a little bit more water. We ended up going to, I believe, a 0.57 or a 0.58, maybe a little bit more than a little bit more. But with the math I'm going to do is all based on this 0.47. Let me put our MSA. MSA is 1.5 inch, and that's from our ASTM C33. But let's get back to our math. Okay, so if we do the math, weight of water over weight of cement equals 0.47, right? So we know our weight of water, so I'm going to erase this, and that's 300 pounds per cubic yard. So if I flip this around, my weight of cement equals 300 pounds per cubic yard divided by 0.47, and that ends up equaling, what was that, 625 pounds? 625 pounds per cubic yard, okay? Now, for the sake of space, I'm going to erase all of this math and put it in the corner so I can save some space. Is that okay with everybody? I hope that's okay with everybody. Now I've got to find my course aggregate content. And to do that, I need to know a little information from what they've provided me already. I have a water cementitious ratio of 0.48, excuse me, not 0.47, 0.48. Before I did that, I should have gone to my next table. I went from 6.3.4a to 6.3.4b, and it says, okay, make sure you're below this for any thin sections. Section is exposed to C or freestyle. We don't got to worry about that crap. We're interior, so 0.48 is going to work out fine. And of course, we did that math to find out our weight of cement. Now we've got to determine our course aggregate content. So our course ag, we're going to go to table 6.3.6, and in doing so 98.2 pounds per cubic foot, that's my dry unit weight, so pounds per cubic foot, times 27 cubic feet in a cubic yard, because I don't care about cubic feet, I care about cubic yards right now. Then what I'm going to do is I'm going to check out my fineness modulus, where here they said it's 2.68. My maximum size aggregate is 1.5, right? So if I use that table 6.3.6, I'm going to use an F or a volume of dry rotted coarse aggregate per unit volume of concrete for different fineness modulus of fine aggregate. I'm going to use a 0.72, and the reason why I did that is I did this whole linear extrapolation. You know, if you wanted to use 0.71, or if you wanted to just say that, well, you know, I'm between 0.73 and 0.71, 2.68 is closer to 2.7 than it is to 2.8 or 2.6, so I can use my 0.72, split the difference there, and in doing so, it gives me a coarse aggregate content per cubic yard, per cubic yard of 1,909 pounds. I'm just going to round that down to 1,900 pounds per cubic yard. It's just normally what we could see the accuracy out of our ready mix plant. I'm not going to start taking this down to a 0.1 or 0.2 or even to a single digit, especially you can if you want to, but the changes that we ended up making in the lab corrected for that. Okay, so I'm going to go ahead and erase my math that I did here, and I'm going to put equals 1,900 pounds per cubic yard. Now, what we could do here to find out our sand is there is a table 6.7.3.1, and we can do an estimate, a first estimate of our weight of our fresh concrete. I just don't like that. We can just take all our weights, subtract it, the weights that we have, subtract it from this number that they give you, table 6.3.7.1. I don't love that. What I'd like to do is I'd like to add up all my volumes, volume of sand. I take my total volume, which I know is 27 cubic feet, and I minus my volume from my water, my volume from my air content, my volume from my cement, my volume from my coarse aggregate, and the volume I have left over in cubic feet from that 27 cubic feet per cubic yard is what I use to determine the amount of volume I have for sand. So let me go ahead and do that. If I take my water, I do 300 pounds per cubic yard divided by 62.4 pounds per cubic foot. That's the unit weight of water, and that gives me, anybody have a calculator? I do. It gives me 4.81 cubic feet. I add to that, so I'm adding all these together, my 0.01, which is my air, times 27 cubic feet per cubic yard, and that gives me 0.27 cubic feet. I add into that my coarse aggregate, which is 1,900 pounds per cubic yard, divided by my 62.4 pounds per cubic foot, times my specific gravity of my coarse ag, which was 2.70. What does that equal? 11.3 cubic feet. And of course, the last thing I have to add in there is my cement, which is 625 pounds per cubic yard, divided by 62.4 pounds per cubic foot. And the specific gravity of cement is 3.15. And what does that all get me? My leftover 7.44 cubic feet for my sand. I'm going to leave that up there for a second, and I'm going to write my volumes for my different things. So here 4.81 cubic feet. This was 0.27 cubic feet. My weight of cement, this was 3.18 cubic feet. My coarse aggregate, I'll write that underneath. That was 11.3 cubic feet. And altogether, that was 19.56 cubic feet. And then to get my weight of sand, it's 7.44 cubic feet times 62.4 pounds per cubic feet times my specific gravity of my sand, which is 2.59. And altogether, that comes out to 1,202 pounds. And I just say it's 1,200 pounds. There's my rounding again. Okay, so there's my weight of sand. For my water, I got 300 pounds per cubic yard. My air, I got 1%. My cement, I got 625 pounds per cubic yard. Sand, 19, or rock, 1,900. And my sand, I got 1,200. Now listen, this is a benchmark. You know, we've got to do the moistures and the absorptions. I'll show you how to do, you start off with, here we're going to go with water. We have this design water of 300 pounds per cubic yard, but we want our batch water, right? And listen, with all these numbers that I give you, you've got to try this out in the lab. This shit is not going to be right for your material. This is going to be a good benchmark, a good place to start. So let's go ahead. So this is all going to be in pounds per cubic yard. So I start off with my design water. I want to get to my batch water. So I take, my moisture, which is and this is for my coarse aggregate, 1.3% minus 0.7%. And I multiply it by 1,900 pounds, per cubic yard, and I do the same thing. Now I'm adding these two up. I'm doing the same thing for my sand. That's the free moisture that I have. Then I multiply that by this. Our new water, our batch water, is 200, we could say 45.4, just 245 pounds per cubic yards. If you divide it by 8.345, you get 29.4 gallons per cubic yard. Okay, so there it is. The one change that I would make is that for the coarse aggregate, you're going to multiply that 1,900 pounds times our moisture content for our coarse ag, which was 1.3%. So this would actually be 1,925 pounds with our moisture content, and our sand would be 1,200 times, and our moisture was 6.3%, 1.063. So this should actually be 1,275 pounds per cubic yard with the moisture. And of course, we're taking that moisture out of our design water. So let us know if you have any concrete questions, any concrete concerns. Don't forget to like and subscribe. Ding that bell for notifications. Have a great day, folks. Talk to y'all later.